Today we are covering Chapter 7, Lesson 5. This is the last lesson before you guys take your test. We covered rectangles, parallelograms, squares, quadrilaterals in general. Now we're doing trapezoids and kites and then we're finished. So please make sure you have your notes open. Things you need to know about trapezoids. Trapezoids are a part of the quadrilateral family. They have exactly one pair of parallel sides. Okay, please keep in mind there is only one pair of parallel sides. And your parallel sides are considered your bases. So these right here that I'm highlighting in yellow is your base, that is your parallel side. Your non-parallel sides are called your legs. Okay, they are non-parallel. Base angles. Your base angles are consecutive, and we should know what consecutive is. You have two angles that are consecutive. Consecutive meaning they add to equal 180. So it would be, for example, this one. These two are your base angles. It's not the ones right across from each other. Okay, you only have two consecutive base angles. So please understand which ones are your base angles. These two right here are not consecutives. They're not consecutive angles. It has to be your two base angles, the two bases. All right, isosceles trapezoid. We've covered isosceles, scalene, equilateral. Isosceles means they're congruent on two sides. So when you're looking at this one, you have isosceles on two sides. Both my legs are going to be congruent. So with an isosceles triangles, I have two legs that are congruent, and that makes it isosceles. Two congruent legs and two parallel bases. You have to know the difference between a base and a leg. All right, theorems. 3 theorems that we're covering. This has to do with isosceles trapezoids. So looking at the first one, if a trapezoid is isosceles, then each pair of base angles is congruent. So this is called isosceles trapezoid base angle theorem. Okay, this is saying that you have each pair of base angles is congruent. So these two are congruent and these two are congruent. Your bases. So here's one base, here's another base. Your base angles are congruent. The next one sounds similar, but it's not the same. If a trapezoid, so they're saying if a trapezoid has a pair of congruent bases, one pair, then it is isosceles. So this is proving it to be isosceles, but the previous one says it is an isosceles triangle. So if we're proving it to be something else, this is going to be isosceles trapezoid base angle converse. So looking at the first one, they're telling us the trapezoid is isosceles, but the second one, we're proving it to be isosceles. All right, and the last one, a trapezoid is isosceles if and only if and only if the diagonals are congruent. And this is going to be isosceles trapezoid diagonal theorem. So we're still dealing with some diagonal lines. Isosceles trapezoid diagonal theorem. And something you have to know about this is when you're looking at your diagonals, these two are congruent, and I'll draw my congruency marks. And then looking at these two right here are congruent, which means the entire line is going to be congruent. Okay, so when I say the entire line, I mean straight across. Straight across is congruent. but you can see what's congruent with each other. So these are all the theorems for isosceles trapezoids. You have your base angle theorem, your isosceles base angle converse, and then isosceles diagonal theorem. All three of these, you have to know them. All right, trapezoids, you have a mid-segment. The mid-segment of a trapezoid is the endpoint at the midpoint. So it's in the middle. It's directly in the middle of your two legs. Okay, this is the complete middle of my two legs. Keep in mind your mid-segment is not from your bases. It is from your two legs. Please do not draw your mid-segment attached to your parallel lines. It is attached to your two not diagonal lines, but your two legs on the side. All right, trapezoid theorem, the formula. Trapezoid mid-segment theorem. There's a formula for this. You have to remember this. This is the formula to get that blue line in the middle. If you don't know the formula, you have to memorize it. So personally, I like to label my bases as base 1 and base 2. Right here, they're representing it as the specific side. But there are two ways you can write this formula. I like to write it as base 1 plus base 2 divided by 2, or the one that's given is 1/2 times base 1 plus base 2. This is the formula for you to get your mid-segment. All right, please write down the formula if you didn't write it down. You only have to know one of them. They're both the exact same thing. It's just written without really looking at that fraction in front of it. All right, kites. Things you need to know about kites. It's also quadrilateral, and it has two pairs of congruent consecutive sides. We should know what consecutive means. And two congruent sides. A kite, I feel like you guys already know what the shape of a kite is, so you should be able to tell what's congruent. So when you're looking at it, this is congruent to this one, and then these are congruent to the other side, so you should hopefully know what a kite is. You're gonna have to wait. All right, looking at the theorem, properties of a kite. Theorems you need to know for kites, there are only two. One is that your diagonals make perpendicular lines. We already covered this for which shape? What other shape gives you diagonals that are perpendicular? Is it rhombus or parallelogram? Rhombus, parallelogram? They're all kind of parallelograms. We need to be more specific. Rhombus? Yeah, you guys are like switching your answers. All right, what about a square? What about a square? It could be a square too. Okay, rhombus and square both have diagonals that are perpendicular. So just so you could see it, draw your little perpendicular symbol on the inside just so you know that it is 90 degrees. Next, looking at the next one. Exactly one pair of opposite angles are congruent. Please understand it's not whichever opposite angles, it's the specific opposite angles on the sides. Because if you were to look at it, A is technically a larger angle than C. So it has to be kind of like your two side angles, I want to say. Okay, so that has to be congruent. Those angles are going to be congruent. So even if I were to draw a line in between the middle, I would still know that this is congruent to this, and this side is congruent to this side. So they're congruent. All right, going on to the examples, we're just going to do 4 of the examples. Looking at this one, this is a trapezoid. We should know that this angle is congruent to this angle, which also makes it 100 degrees. And then we should also know that this angle is congruent to this angle. We are finding the measure of angle A. looking at it, these two angles are called what? Good. These are consecutive angles. When they're consecutive angles, what do they add up to equal? 180. So I'm going to take my 100 degrees, and I'm making it 180 minus 100. And what am I going to get for angle A?
80.
Good. 80 degrees. This is for angle A as well as angle B. And again, it has 4 sides. If I have a shape with 4 sides, my sum of the interior is 360. So 180 plus 180 gives me 360, which is true. So it's not hard. You just have to remember the properties. All right, looking at example 2, same thing. This is a trapezoid. I have this is congruent to this side, and this side is congruent to this side. So if this side is 49, what should angle E be? 49. And E and F are what kind of angles? Consecutive angles. So what am I going to do with that 49? Good. 180 minus 49, and what am I going to get?
131.
Perfect. 131 degrees. So far, we just subtracted. That's it. We're not doing anything major. All right. This question, please label your information. We know that our diagonals are congruent. So first thing they're giving me, KB is 21.9. This is KB right here. MF is 32.7. Orange. MF is 32.7. And they want me to find BF. So I'm going to label what I have. KB is 21.9. MF is 32.7. And I know what's congruent. I know that these two are congruent and these two are congruent. How would I find the measure of BF? Good, 32.7. All I have to do is subtract. Minus 21.9. What am I going to get if I subtract correctly?
10.8.
10.8. So this is going to be 10.8. And this side is also going to be 10.8. And this side is 21.9 to equal 32.7. So you have to know what's congruent. You have to know the properties. And the last question. I have a kite. Labeling information for a kite. The measure of DAB is 54. And CDF is 52. What other angle do I also know is 52? CBF is also 52. And then I already know that my diagonals are 90-degree angles. Looking at this, we are trying to find the measure of angle C. I have triangles within my kite, and that's something you need to know. I have 1, 2, 3, 4 triangles, but then I have 5, 6, 7, 8 separate triangles if I were to break this up. So in order for me to find C, I know that this is a triangle, and the interior measure of my triangle is 180 degrees. How do you think I could find C? Yes. Good, so I'm going to add 52 plus 52. I'm going to get 104, and what do I have to do next? Good, 180 minus 104. If I subtract correctly, what would I get? 76, and is that my answer? Yes. Angle C is 76 degrees. Not too hard. You guys are having your test on Wednesday, so Monday and Tuesday are going to be review days.